All right, 11.5 part 2, we're going to be talking about similarity and density. So density is a concept you might be familiar with from physics or chemistry. Density is the amount of matter in an object. The amount of matter in an object. And the formula for that is the mass divided by the volume, and that's kind of where it comes into play for this chapter. So here I have a diagram of the dimensions of a standard gold bar. So we actually do have gold in this country. It's an actual place. It represents kind of the income. But so a gold bar has a density of 19.3 grams per cubic centimeter. So I want to find the mass of a standard gold bar. So there's some information we need to know. Now, something you might notice is that this is grams per cubic centimeter and this is inches. So we're going to have to convert those. So something that we need to know is that 1 inch equals 2.54 centimeters. So let's convert these to centimeters, because then we can find, we have the mass and we can find the volume. Well, we're trying to find the mass. So we have the density, we have the volume, want to find the mass. So essentially, if 1 inch is 2.54 centimeters, we just have to multiply. So 7 times 2.54, that gives us 17.78. So it's the length is 17.78 centimeters. The width is 3.625 inches. I'm going to include all the decimals because I want to be nice and exact. And then you multiply that last one by 2.54, you're going to get 4.445 centimeters. So I want to find the standard mass. So I have density equals mass over volume. I have the density, it's 19.3 grams per cubic centimeter. I don't know the mass, and I can find the volume, because volume is length, width, and height. So 17.78 times 9.2075 times 4.445. So the volume of this gold bar is 727.69 centimeters cubed. So how would you get M alone? Well, we're actually gonna multiply both sides. Now keep in mind, this is 19.3 grams per centimeter squared. This is 727.63 centimeters squared. So when I multiply both sides by 727.69 centimeters cubed, these cross out. And these centimeters cubed cross out, which is why the mass you're left with in grams. So if we multiply that, we get 14,044.38 grams is the mass. Don't worry too much about the canceling, but it is something you'll see definitely in chemistry when you're converting units. We can also do similar solids. So similar solids are two solids that have equal ratios. So that ratio is that scale factor, going back to a previous chapter. So equal ratios corresponding with bases and the height. So essentially, if the bases and the height are all have the same scale factor, that's what you're going to work with. So remember, to find the factor, you do image over pre-image. I know how much you've missed that. So it's image over pre-image. So for instance, here, how to find the volume of similar solids. So I have, the radius is 3, the radius is 6, the volume is 45, the volume is what? So essentially, to find the volume of similar solids, we don't multiply by k, we multiply by k cubed because we are in volume at the moment. So here, what is k? Well, it's the image over the pre-image. So what do we have that for both of those? We have the radius. So we have the radius of cylinder B. We can put it over the radius of cylinder A, your pre-image and your image. So the radius of B is 6. The radius of A is 3. So our scale factor is 2. We don't want to just double it. It's not just 90. We're not doubling it. We are cubing it. So the volume of cylinder B is going to be the volume of cylinder A times k cubed. So it's going to be 45 pi, you can see the pi down there, times 2 cubed. You do 45 pi times 8 in your calculator. 2 times 2 is 4 times 2 is 8. You're going to get 1130.97, and it's still centimeters cubed. So let's do another example. I have prism C, prism D. Side of 12, volume of 1536. Side of 3, volume of something. So to find the K, image over pre-image. The image is what we want. So we have 3 and we have 12. That gives us a fourth. To find the volume of this prism, we want to take the volume of the first one and times it by k cubed. So I have 1536 times 1/4 cubed. Keep in mind when you cube something like that, either put it in your calculator as 1536 times and then the whole thing cubed, all right? Oh. Make sure, because the way that cube works is being distributed. So unless you want to remember how that distribution goes, make sure you're putting it into your calculator correctly. And that gives us actually exactly 24. So that's density and similar volume. Please get started on your 11.5 homework.